Okay, now we are going to solve the block in the inclined plane. Let's list the force acting on the object. So we have gravity down, it's called Fg or weight, normal force, friction, and it's kinetic friction because the block is accelerating. The free body diagram, we prefer this to be the x-axis for convenience, and this is the y-axis. And if you make the axis in this direction, that makes your life easier, as you are going to see in a second. So this is mg, friction, and normal force. So in the x-axis, you have this component. This is the angle. This is the angle of the ramp because they are mutually perpendicular. So this size over here, this size over here is perpendicular to this side, and this one is straight down is perpendicular to this side. So if the two sides are perpendicular to the two sides of the angle, then the two angles are equal. So this side over here is opposite, so this is mg sine of the angle, and this is adjacent, this is mg sine of the angle. So in the x-axis I got positive mg sine of the angle minus friction and acceleration in the x-axis. In the y-axis I have normal force minus mg sine of the angle. Cosine. This is cosine and this is sine. Mass times acceleration in the y-axis. And that is the reason why you put the axis like this. Because in the y-axis, the block is not moving in the y-axis because that will be getting into the surface. So this is 0, and that is the reason why you put the y-axis and the x-axis like this. And from here we solve for the normal force. It's going to be equation 1. And here we solve for the acceleration. This is 1 and this is 2. And this is the empirical equation that relates normal force and friction. So we substitute n in here, and now we substitute, this is equation 3, so we substitute 3 into 1, and I get if I divide by the masses cancel. That's quite interesting. When the mass disappears from the equation, means that the acceleration is independent of the block mass despite of having friction. And the acceleration of the object is g you could take g as common factor, and this is the acceleration of the object. It's interesting because it's independent of the mass of the object.